So first of all, you all look a lot more awake than I had expected at 9 o'clock in the morning. So you either had your coffee or your Mountain Dew or whatever it is that you need in the morning to get going. If you're in this session, it means that you've already made up your decision about what you think about Google coding standards. So I'm happy to see you here. But it might mean that you're still a little unsure what to do about all the extra baggage we have to worry about for writing a class with C++ 11 and 14. I work with Kira Consulting. My name is Michael Caisse. Kira is a Latin word. It means to put into motion or to conjure, which is it's a pretty good name for the company. One of the people that works with us is Joel de Guzman, who is the author of Boost Spirit and Fusion and other magical libraries in Boost. We spend a fair amount of time helping companies learn how to program in various odd ways that are hopefully a lot more efficient. A lot of teaching, a lot of working on architectures, a lot of library writing, a lot of metaprogramming. And if you've seen one of my talks before, this is not one of those. We're not going to be talking about metaprogramming. We're not going to be talking about some esoteric, strange thing inside of libraries and how to abuse them. We're going to be talking about something that seems to come up a lot when we're working with different companies. Started about 2010. I seem to get a lot of requests for, what do I do for writing the canonical class? It used to be so easy. I used to know what to put inside of a class. I knew how to write it. I had a list of rules. I had a checkbox. And I'd click on through those, and I knew when I got done, after a little bit of testing, things were going to work properly. Or at least I had a feeling that they might. And then things became complicated. Here's a spoiler alert. I'm not going to give you a list of rules, okay? And so if you're looking for that, you may want to find another session now. But we're going to talk about a lot of different things here. Mostly if we can get the clicker working. And the clicker will not be working today. All right, so what we're going to talk about is how to write just a simple class. This would be your textbook equivalent of a class. This would be the thing that you would have started off, you would have seen inside of your very first chapter of a book. And I get asked that question, how do you do it? And what they're asking, when people ask me this question, they're asking for what are the list of rules? What do I need to know in order to ensure that my class is going to do what everybody expects it to do, what the right thing is? So how many here like rules? Wow. Okay, now honestly, how many of you like rules? So this is an odd group, I have to admit. So usually about 60%, 70% of the group will raise their hand. They like a set of rules. And so this might work out really well. So first of all, there are lots of proposals about rules. There's this rule. Let's go ahead and have a rule of 3. Then there's let's have a rule of 4. How about a rule of 5? There's another proposal that we don't have any rules. That's actually not what it says. But there's a rule of 0. How many are familiar with some of these rules? All right, I don't like rules. So I particularly dislike fabricated rules. The problem with rules is we stop engaging and we stop thinking. I watched Jessica set up the cameras before we got going here. And I bet she's done this a lot, but she was super careful about a lot of things. She double-checked. She made sure that things were laid out the way she wanted them. She spent a lot of time doing that. I didn't see her back there with a list, a checklist. She probably has an idea of what it will take in order to produce the outcome that she needs. And she was thinking about that as she went. You may have heard this guy before, Scott Myers. He wrote this couple books about effective programming. Rule number 7. I was going to actually just ask how many people knew what item number 7 was. So look, here, this is the problem. So Scott writes this great book, right? And He's got items, and they have titles. And then they have text that goes with them. But what seems to happen is we take the title of the item, and then we summarize that into something shorter, because that's too long. And we end up with, if you have a base class and you inherit from it in any way at all, it needs to have a virtual destructor. What is the result of having a virtual destructor in your base class? It has a vtable. It potentially has a bunch of stuff you don't need, right? So if you never plan on having runtime polymorphism, you don't need a virtual destructor. Your compiler is going to complain. See, it even gets worse. Your compiler is trying to help you do the right thing. It's trying to help you think, okay? What you want to do instead is you want to think about, what do you need in your class? All right, so I like guidelines. Guidelines aren't so bad. But you have to engage your brain, right? So you can't just blindly have a set of guidelines. Most teams need guidelines. There are a variety of different reasons that you want guidelines. One of which is it helps you think about what you're going to do before you write it, and it helps you think about how you're going to defend your code in a code review. How many of you have code reviews? Oh, awesome. So I'm moving out here. I don't know where you're all from, but this is pretty cool. Rules and guidelines, they're not replacements for mentoring through code review. Very often, we have sets of rules and we have sets of guidelines because we've seen something bad in code somewhere along the line. And we're never going to want to see that thing again. And so we impose a bunch of rules when what we really want to do is mentor through code review, and the individual that is writing the code that we prefer them not to write, we want to help them along. We want them to understand how to make the decisions and trade-offs along the way. All right, so typically after I try to dodge the question from my client of what the rule sets are, they just ask, so how should we write a simple class? It's almost like they don't even listen. I don't know. So, okay, in C++98, what's special about these? Yeah, okay, so these are compiler-generated methods. If you don't supply one, and there are a variety of different rules, you're going to get one. And you're probably not going to like it. So these are things that we have to worry about. And when people ask about how to write the canonical class, they're basically asking, what is it that I need to do with these? That's nice. We have a few more in C++ 11 and 14, which is part of why the question comes up. What do I do with these other things? I've got this thing called move. I have rvalue things. What do I do with these? I can construct them. I can copy them now. Yeah, it's starting to get messy. And then, you really need to start thinking about probably custom swap, initializer list, noexcept, and const expressions. Those need to be in your bucket list. So pretty soon the rule list is getting large. It's definitely not 0. It's not 5. There's a lot of things that we have to consider along the way. All right. What does it mean to default construct an object? Pardon me? Member-wise construct. This is no right answer. What does it mean to default construct something?
Every member is default constructed.
Every member is default constructed? Any other answers? Let me help you out a little bit. So what does it mean to default construct a standard vector? Okay, it's empty. Can you call front on that? Yeah, you could call it. That's right. It's not going to stop you from doing it. What will happen? Okay, so when we construct something, It's in a state in which we're allowed to do certain things and there's certain things we're not allowed to do, right? Those are the invariants of this particular item. The invariant is based upon what just happened. It was default constructed. There are some things that I can do with this object. How about thread? What is a default constructed thread? What does that mean? Yeah, nothing, right? It's just waiting to become something. It's hanging out. It's a container. How about this? Unique pointer. So unique pointer happens to be constant expression when it's default constructed. And all just waiting for something again. How about this? STD reference wrapper. Yeah, so the question up in the front is, can you default construct one of these? Can you default construct a reference? Does that even mean anything? No. Okay. So this is what I want you to think about. I want you to think about first, is your type default constructible? I want you to think about the semantics of what does it mean to default construct your object. Not about what happens internally. All these members get default constructed. Don't worry about that initially. Initially think, the thing that I have, should it be default constructible? And what does it mean if I write a default constructor for it? So we do a lot of library writing. And I can tell you that people coming to you later and saying, but I have this type and it doesn't have a default construction. How am I supposed to use it with your library? That's like the worst news in the world. I hate to hear that. And very often, early on in my career, I used to push back and say, what do you mean you have a type that's not default constructible? I don't even know what that means, right? But these exist in real life. And they exist typically when somebody's been thinking about what the semantic is of their object and whether or not it should be default constructed. So first step, very easy. You're going to write a default constructor. Should you write a default constructor? What does it mean for your object to be default constructed? All right. If your object cannot be default constructed, I recommend you write this. What is the advantage of doing this? Pardon me? Okay.
It expresses the intent that you don't want.
It expresses the intent. So, next spoiler alert. I believe you should be explicit. And the reason is, when somebody looks at your code later, they don't have to worry about whether or not you understood all the particular rules that were involved for that version of compiler. And we're going to see some of the interplay in that in a moment. So yeah, you actually get something that says, use of deleted function, foo. So foo, as far as lookup goes, it exists, but it has been marked as deleted. And so we get a nice error message, right? Very nice. All right.
If I think you get it at compile time instead of at link time, which is so cool.
Yeah, you get it at compile time. Yeah. All right. So this is default constructible. It kind of looks like this, right? In which we have compilers basically making something that, right now, in our purposes, looks like an inline constructor, and we have some initialization. What can you tell me about I?
Zero. Whatever that. Whatever.
I love this question. Let's start with bar. What can you tell me about B? Okay, so we can tell B is going to get default constructed. It's some user-defined type. I is garbage. And you should do something about that, right? Okay. So special member methods, you can do a couple different things with them. Implicit means the compiler is going to give you something. Do nothing, you can take whatever the compiler implementation is. The other thing you can do is explicit. You can define what you want. When you define what you want, you could either have something that's user supplied, you can mark it as deleted, or you can mark it as default. You could explicitly say, I want whatever the compiler would have generated at this point. All right. Take a moment and look at this slide. And then I'm going to take comment on it. All right. Any comments? Pardon me? Okay. There's a comment about it needing a copy constructor. Anything else? Okay. Needs to be explicit. Anything else? All right, this is your chance to get it out of your body, because we're going to use this example as we move forward. You know, that is an equal sign of, and I'm clearly having video issues here, aren't I? The slide deck will be available. Oh, okay, so comment unique pointer or a vector. All right, so thank you. Pardon me? Default constructible. It is default constructible? Okay. Oh, look, we already have disagreement on whether it's default constructible or not. Yeah.
Does I don't know the rule for if the things are on the same line, whether it's going to initialize buffer beforehand.
For the order of initialization? All right. Now that we got that out of our system. So this is an example piece of code that we're just going to use. All right? So buffer, the reason that I have this isn't because I write horrible code. It's because it's going to represent something for the rest of our talk. Buffer is going to represent some resource that is not controlled internally with the stack of this object. It doesn't come up with the stack and go away with the stack. It just represents some resource that is external that I have to take care of. All right? So don't get hung up on, Michael put a raw pointer in the middle of his class. What is he thinking? All right? Yeah, I did it on purpose. So that we can talk about resources that we need to manage. All right. So here it is. Let's talk about it. Let's talk about it in this context. I have the circular, I create it, and then I assign it. That is an equal sign. Tell me about this. Okay, we have a leak. We have anything else? Okay. Double delete. This is causing us issues, right? And this is why we have those rules, is because this stuff makes us sad. If you're lucky, you get something that tells you that you had a double free. And then you go off and you try to figure out where it is, right? So let's talk about this. What could I do to fix it? Well, is it fixed? Okay, so the comment is, what is your definition of fixed? For some variations of the word fixed, this is fixed. Now I want you to, so those who have noticed, we removed the destructor, and I want you to keep this in mind, all right? We removed the destructor and the problem went away. And there's something actually important in that correlation, not just a joke. All right, so we could do that, but we're more into writing good code and not just job security. So let's fix this. And we could fix it this way, right? We could say, you just can't copy these things. They're not copyable. Okay, how many people think this is a good fix? How many think this is a lousy fix? So what's interesting, you don't even know about my requirements and you think it's a lousy fix. So this is what I want you to think about. Just like we were talking about the semantics of whether something is default constructible or not everything is assignable. If you're writing assignments and default construction just to make things nice and work with containers that you have or other libraries, think again, right? Think about what the semantic is of the thing that you have, and especially now with move, we are able to take care of a lot of the little warts that we had before where we just decorate our classes galore in order to make them work with containers. We don't have to do that anymore. All right, so it might be that my requirement is such that you can't go around copying these circular things. It just doesn't make sense. And therefore, this would be a perfectly fine solution. All right, but most of you didn't like it. So let's go ahead and write a copy constructor. What should the copy constructor look like?
Depends on how you're going to use it. You don't copy on write.
All right, depends on how I'm going to use it. Copy on write is perhaps an example. So what, from a user's point of view, user of this particular item, do they care whether it's copy on write or some other? Okay, we have some yeses and some nos. Those of you who are saying yes, who would like to throw out why that might be important? Yeah, go ahead. Pardon me? Performance reasons, all right? Semantically, you don't care, right? Though, I have this thing, I need it to be copyable. It's a kind of, in some regards, it's an implementation detail whether I get to copy them fast or they're get copied slow, or how many bugs I get reported against my code. All right, so let's go ahead and write one. I'm just going to go ahead and new one off, and I'm going to set my head and my tail and the size, and then I'm going to use std copy. Why should I use std copy? Should always use algorithm. Thanks you, James. That's right. You should always use algorithm. std copy is going to select for you the most. Where's Chandler? I should use the word performant. You're going to get the best way to copy whatever it is that you have if you use std copy. Use std copy. All right. And then I'm going to set up my head and my tail. Life is going to be good. What does my assignment operator look like? Well, my assignment operator is a little different, right? When I have a brand new object, I don't have to worry about what might be inside of the object. I don't have to think about that. So for an assignment operator, I have to worry about, do I have something already here? Because I got to take care of that. I got to clean it up. I've got to do the right thing. And so we take care of some cleanup, and then it looks a lot the same. So the reason that copy constructors and assignment don't look the same is because one is a brand new object, right, coming to life, and one of them isn't. And while you might be, how many write this in an assign method? Okay, there's a couple. So some people will take the assignment part and stick it somewhere and just call that. We'll talk a little bit more about that. All right, so here's the question. Why did we have to add it? What is it in this class that required me to add these?
A resource.
Okay, so one answer is the resource. I needed a deep copy.
Why do you want to move to the container?
This just represents any resource at all. Where did it blow up? Where did we start having problems? At the destructor. And I want you to think about that. It's not the fact that we just have resources internally. It's the fact that we're doing something interesting in the destructor that requires us to have to think about assignment operators and copy constructors. If we weren't doing cute things inside of our destructor, we very likely would not have to worry about what to do about copying these. All right. Okay, a destructor implies changing state outside of the object being destroyed. If you only care about the state internal to the object, you don't care what's happening at the destructor. It just goes away. If you have to do something about state that's outside of your object, it goes inside the destructor. It's the red flag that bad things are about ready to happen, and more importantly, you're not going to like what the compiler is going to give you. So here's the question. Is the opposite true? Does the existence of a copy constructor and assignment operator, does the existence of a copy constructor and or an assignment operator require a destructor? All right, let's change this around. I now have a buffer of 10 elements. We can do this also with std vector. So now things have changed around a little bit. My copy constructor and my assignment operator kind of basically do the exact same thing. Do I need a destructor? No, I don't need a destructor, right? I'm not actually taking care of any state that's outside of my object. Everything is contained inside that needs to be cleaned up. But I have weirdness that I have to take care of when I'm copying and assigning these things. I've got to move some pointers around. I've got to make sure that in particular, head and tail are pointing to the right spot. If I didn't have to worry about head and tail, this would have just worked fine. So just because you see an assignment operator or a copy constructor doesn't mean that suddenly you have a destructor. All right. How many have seen this? Oh, come on. Everybody's seen this, right? So I remember seeing this just a few months after I started writing C++. And I loved it because it made life easy for me. I didn't have to think so much anymore, right? It gave me some rules. And the rules are true. But if you just stick to the rules and you don't think about the semantic of what you have, and you just blindly start coding them, you're going to miss a lot. So the reason that we're doing all this is because the compiler's implicit help is going to hurt us. So in the United States, we have this thing called the Miranda warning. If you watch any police anything, you'll have seen this, heard it. If you cannot afford a lawyer, one will be appointed at public expense. How many of you are jaded? You know, I hear that and I think, I don't know that I really want one at the public's expense. I mean, wouldn't I want my own lawyer? I don't know how that works out. The same thing happens here. This is the compiler spin version of it. If you do not provide a copy or assignment operator, one will be appointed by the compiler at the expense of your schedule and your sanity. All right? Think about every single one of the special functions and what needs to happen with them. All right, here's the eye chart. On the top, this is what the user does. This is what the compiler will do. If you do nothing, you're going to get a bunch of defaults from the compiler. If you provide a default or other constructor, you're going to get defaults except for the default constructor. For the copy constructor, if you provide one, you now have a default copy assign and a default destructor. Copy assignment, and so forth, move constructor. We're not going to spend a whole lot of time on this, but what I'd like to point out is, first of all, we've got new rows, right? We've got things that the compiler is providing that we didn't used to have to worry about because they're new language features. And in a change that's going to be occurring, the rules are going to be changing. So if you are on C++ 11, these are rules. And as you move on, your rules are going to change again. What I want you to take away from this is that there are a lot of rules. there are a lot of things that the compiler is going to do for you. And it's best that you are explicit about what you want done, using the default or the delete for each of those special members. All right, so let's move on. Here's some motivation for move. What is this doing, this piece of code? Okay, vector of 1,000 strings, each with 1,000 spaces. All right, and then we're going to do what? All right, we're gonna insert something at the front of the vector. What will this require of a vector? What does it have to do?
Shift all the other ones.
Yeah, it's got to do some shifting, right? All right. So we need to shift some things around. I want to insert this at this spot. I'm going to have to go and shift all these down to the end so I can make room for it and put it in the front. And in your poor C++98 compiler, what does this mean? We got lots of copies, right? We don't. What's inside of a vector? A pointer to some memory. Okay, so we don't want to necessarily be copying a bunch of stuff around. We would prefer to move the guts of one thing into the next slot and very quickly move things down the row. At the end, we don't care about the final thing. So let's take a look at something else here. I've seen this actually come up a couple times already in the last 2 days. What is circ? What does circ represent? Just by looking at the signature. I heard it over here. It's an output parameter, right? How many people like to put output parameters inside of your argument list? I mean, there's nothing natural about putting output parameters inside of your argument list. What makes sense is the inputs go in the parameter list and the outputs get returned. That's what makes sense, right? It's easier to reason about that code. Every time you see something like this, you have to stop. You got to go and look to see, did they forget the const? What are they mucking around with? Oh, is it really an output? Was I supposed to do something with it before I gave it and passed it in? There's a lot of mental work that has to occur in order to make this thing work. Very annoying. Okay. Wouldn't this be a lot better? Wouldn't this be easier? This is easier to read if I could just do that efficiently. Okay, how about this? I've got some type, my special type, and I'm going to manipulate it, do some things, and then I'm going to push it into some storage. So I'm setting this thing up, I'm throwing it into some storage, and it's going to hang out here for the rest of its life. I don't really want to make a copy of anything. I just want this thing to now be here as opposed to where it was before. There are a lot of things that we sometimes will do in order to play tricks around this, right? We'll just get one back there, and we'll get a reference to it, and we'll start initializing it. But the code then is harder to reason about. Okay, so one of the things we don't like about the previous is that it's harder to reason about, and what we really want to do is just suck the guts out moving on. So move, the motivation for move was an optimization. And I want you to keep that in mind, because we're going to have an argument here in a moment. So the optimizations are the ability to recognize that the object is temporary, or the ability to indicate that the object is no longer needed. It's expiring. It's going away. The other is move-only types, right? That works out to be pretty nice. Can somebody name some move-only types? Thread. Thread's a great one, right? Thread's a move-only type. Unique pointer. There's some. So semantics of certain things are that they're move only. You probably have some in your code base that have comments around them and code review saying, don't move, or don't copy that thing. It happens to be copyable because we need it to be copyable for this really weird esoteric thing. Don't do that. Use move. All right, this is an rvalue reference. And it is going to bind to an R value. Does everybody feel like super good about R values? Know what they are? Okay. So here we have foo, bar, R value, and this is an L value reference. So bar, Z, and I call foo, passing it Z. What's going to get called? Wow, we're already disagreeing. Okay, well, maybe we'll come back to this slide later, and then we'll ask. This will be good. This will be good. It's all good. All right, so same thing, same signature. How about this one? Get bar is going to return a bar. In here it creates one and it returns it. I call foo with get bar. What is this? All right, we're in agreement here. This is an R value, okay? First of all, you know it's an R value because it has no name, right? You can't get in there and just like figure out how to get the return type, or excuse me, the return value by name. It doesn't have one. All right, this was part of our motivation here. We wanted to make this an R value. Currently, it's not. It has a name, right? And what I'd like to do is somehow tell the compiler, you know what? I know it's a named value. It's not a temp, but I'm telling you, this thing's going away, and I never want to see it again. I'm not using it here. You can have it. So how many of you read the standard for fun? Awesome. All right. How many of you read the standard? Michael, I love it. How many of you read the standard when you need to go to sleep? So the standard's fun, right? The standard is go from here and skip to there and skip to there. I had heard a lot of talks on R value things. And I can tell you, honestly, I walked away from each of them going, I'm not really quite sure what they said. And for hopefully not too many people from the standards committee are in here. I don't find it often that I open up the standard and read it and walk away with a super clear picture without sitting and thinking about it for a while, right? And spending some time to really understand all the implication. This is out of the standard, and I love this picture. If somebody had thrown this picture up initially when I was learning R values, I would have been, oh yeah, well that's obvious. Okay, so expressions can be G values or R values, whatever those things are. Let's help, okay? Because I don't know, there's a limited number of keys or characters or something. So these are generalized L values, and then we have R values. And then we have now pure R values, PR values. A pure R value has no name. They are temps. You don't have one, okay? If you returned it from a function, like we have previously, we returned the bar. If you assigned it to a variable name, it is no longer one of these. It is now an L value, okay? It has a name. There's this really cool little thing here, though. We want to deal with R values. And notice, R values can be either these pure R values, they're nameless, or they could be this expiring value, X values. And we can get one of these from a generalized L value. If we have something that's named, in essence, we can just cast it to something that we're saying is expiring. And therefore, we now have something that looks like an R value. Well, what I want you to take away from this is there are two types of R values that you're going to be dealing with in your code, and I want you to think about that. You're going to be dealing with ones here that are pure. They are not named. You can't get to them. There will never be a problem with moving these things. Then there are these other sets in which you're going to tell the compiler that this thing's expiring. It's going away. And there may be consequences when you do that, depending upon what you do with it later. All right? So we got these two types here. This is how I tell the compiler, I would like you to make this an expiring value. So this will make it now compatible or will bind with an rvalue reference. What's inside move? It's just a cast. It's just a cast. All right, so an R value from an L value is an X value. So R value from an L value is an X value. What do you notice about the difference between the copy and the moves? Copy constructor, assignment operator, and the move versions of these. No const. Why is there not a const? Yeah, you're going to suck the brains out of the one, right? You're going to make it into a zombie, and you're going to have to modify it. You're going to mutate it. Look, you can put const there. I have not figured out how to abuse that part of the language and what I would do with it yet. But I'm sure there is something you can do with it. I just don't know what it is yet. Having a const R value reference, I can't think of a reason that it would be cool yet, what you would do with it. The whole intent is that you want to modify the state of that thing. And we're going to talk about that. There are lots of things about what you should do with that. Let's just ask this. What would it mean for one of your classes to be moved? What does that mean? So, how many of you believe that once you move everything out of the class, the end result is that you should be able to move something back into it or have it be destroyed? Beyond that, you don't care. We've got, okay, I have a depends upon the class. 25% or so. So you guys are in the destructive move camp, okay? By the way, you're in the destructive move camp with some pretty good folk, so don't feel bad about that. How many of you believe that once you move out of something, all the invariants of whatever that thing is need to still be maintained? So then that's another 25%. There's about 50% of you who don't know and are ready to be persuaded one way or the other to one camp. So there are a lot of heated debates about this, on what you should do. Let me tell you now, this is my rule. Make up one for you. Make up one for your team and your company so that you know what it is. Read a lot about this, okay? I happen at the moment, I probably even shouldn't say this on tape, I happen at the moment to still live inside of the destructive move camp. Now, there are some problems with that. The problems have to do with the fact that I might have an expiring value. I told it was going to be moved, and then I use it afterwards in a way that, that should not have been. The invariants were violated afterwards. And when you're writing generic code, it's sometimes hard to control that. It's very often to understand that a move occurred. What I would really, really like is that pure R values were distinct from expiring values, but I don't know how many more operator ampersigns I can stick in there. So.
Why don't you want to keep the variance preserved performance?
Yeah, so I know this is going to get down to small amount of performance differences, right? But fundamentally, if you say that the reason for writing move operators and for spending so much time on them compared to just writing swap, move as swap, is for that one extra load or that one extra whatever it is, then it's a performance thing, right? It's a performance optimization. And to me, it's very much like you had a pointer to a bunch of memory, you called delete on it, and then afterwards somehow you used it again, okay? You probably shouldn't do that. Now, there are a lot of reasons why that's going to happen, perhaps, and you might be upset. All right, so let's move on here. So ask yourself, what does it mean to have your class moved? What would move mean for something like this? All right, we're going to transfer ownership. And in doing the transfer of the ownership, I heard we can do a shallow copy, was one suggestion. It would be nice if I did something, though, perhaps with the thing that I'm copying out of, and so I'm just going to set it to null pointer. All right. All right, how about move assignment? So move assignment is a little bit different. I need to still take care of cleaning some things up, possibly. And so at the moment, I'm thinking about that by deleting this. What is it that I am moving out of? The source of the move, what do I know about that object? It's not going to be used again. All right, can that help me out? Sure, it could. So depending upon what's going on, for example, if I have a chain of things that are occurring, I might as well just swap and then take the delete on the final destructor of the very last item that's maybe in this chain of actions that are happening. And so very often, something like this is far more efficient, right? All right. This, by the way, is the proper way to write with swap. Using std swap and then swap internally so that if swap has been overloaded elsewhere, you get the proper swap, right? Don't call std : swap. All right, let's take a look a little bit at this. So I've got this amazing stuff method. It's going to return a circular object. Creates one and returns it. What's going to happen here? So constructed one. I'm calling amazing stuff, and I'm assigning it to A. What's the end result? How many what's am I getting? Constructions, moves, assignment operators. So I'm getting a default construction right here, and a default construction again right here, and a move assignment, and then my destructor, my circular destructor. Okay, let's make a change now. And the change is this. What happens if I do this? Okay, there's definitely one less construction for sure. Okay, move assignment. So this is what happens. I have circular default construction. And then, I'm sorry, construction. And then here's the destructor out here. I just constructed one. That was it. So what happened to my move operator? All right. So what costs less is, we don't care about standards at the moment. What costs less than a move? No move at all, right? So there's RVO or in RVO, return value optimization. Don't break it. There are lots of ways to break return value optimization inside of your classes when you write them. Don't do that. Because what's better than not moving, or than moving, is not moving at all. So there are a couple of ways that we can break it. So I think it's every time that there's a new feature that comes out, you see it everywhere in code suddenly. It is amazing how many code bases that I've opened up and people are returning a moved value of something. Don't do that, all right? This is bad. This is going to break your return value optimization. This type of thing is going to break your return value optimization. All right, what would move look like for this? A lot like copy, yes. So move looks a whole lot like copy. Look, you know, move is not magic. Move is saying that I've got something out here in the heap, and I have a stack, right? I don't magically move things around on the stack. That doesn't happen, or I don't know what that would mean. That would be cool now. Wow, we need to think about that. Okay, you're just copying. You're sucking the contents out of that area in the stack, and you're sticking it somewhere else, right? So that it'll still point to the heap. And then this is going to go away. So move is copy when there are no externally managed resources. Let's talk about noexcept real fast. So some containers have a strong exception guarantee for certain operations. And if you can stick within that, you get an optimized version of that. Here's an example, std vector insert. So what does that mean? It means this. It means that you're going to write noexcept because you're going to be telling the compiler that this is not going to throw an exception. And you're going to think about it really hard. Because if you write noexcept there and you throw an exception, you'll probably be pretty sad. You'll also want to consider it for your assignment operators. Is this noexcept? Pardon me?
Depends on which swap is going to call, I guess.
Oh, I guess you could do wacky things in swap, couldn't you? Don't. Wow, that would, you're scary. All right. Let's go ahead and move on here. We're running out of too much time. So let's talk about this. Because as you're writing these classes, they become more complicated, right? We now have perfect forwarding. And perfect forwarding solves this horrendous problem that we had before, which was having to write more than you can imagine variations of constructors and such in order to take what I have and get that real that real thing moved on to the next thing that's passing it on. What are all the decorations involved? It was a pain. So this is awesome in some ways, and it's a pain in other ways. So I have this circular. This is not, right? This is not an rvalue reference. This is an rvalue. This is a template with something that looks like it, ampersand, ampersand. It means perfect forwarding. It means something else. It's a different context. We do that right in the standard because can you imagine introducing something new? Can you imagine that somebody's code base is going to get broken because you decided that you liked the new keyword, whatever it was, or whatever, whatever so things get reused. And this perfect forwarding thing, let's take a look at these. What's going to happen here? So the first one I'm taking, and I have an int I, and I'm constructing my circular with it. Here I'm just constructing my circular with the literal 8. Here I'm constructing a circular B with an A, and this is an assignment. Ready, set, go. All right. So perhaps a little bit surprising, we get some of what's called a universal. So we're getting our perfect forwarding version called here and there. And we have the default constructed ones here, of course. And then, oh my goodness, another one here. And then, oh, another one here. Look, if you put this in your code, you pretty much have taken over the world of construction. And you need to think about that. It's going to be surprising the first time you run into it. Okay, here's another surprising one, initializer list. I would really like to initialize my circular thing with a list of circular things. All right, same stuff. and initializer list wins. Always. That potentially can make you really sad. When you write an initializer list, think really hard about what that just meant. And whether or not you really need an initializer list, and how you're going to take care of the problem that everything wants to construct with it. All right, so let's end up here with a couple of observations. So we've got the rule of 3, and we've got the rule of 4 and 5, and the rule of 0, and we've got this eye chart. What I want you to do is I want you to walk away and think about something a little bit different. I want you to think about not the rules that we have, not the eye chart at the moment. I want you to think about the semantics of the thing that you're writing. Take the time and the care, just like Jessica did when she was setting her camera up. Think about, for every single class you write, what you expect that class to do. And spend the time with every one of the special member functions to understand what it should be. That will end up with code that's not only easier to understand when you're writing it, but it'll be easier to understand for other people who need to maintain it later. They'll know that James, when he didn't actually put in the copy constructor, he didn't mean to put in the copy constructor because he deleted it. He wrote delete. That's what he really wanted to do. He wanted it to go away. Or he wanted the default version. He wanted the compiler version because it was perfectly fine and fast, so he wrote default. Oh, don't copy and paste anything. No, don't do that. Rules, okay, no, don't be a programmer, right? That's what you're paid to do. You're paid to sit around and think about things. And while the rules and guidelines are great in order to help get us to the point where we have things to think about and things to worry about, take your time and spend on each and every single one of them. So look, carefully consider each of these. Consider the semantics first. Consider performance. There's 2 types of performance that I want to talk about right now when you're considering these. The runtime performance, but I want you to consider the corporate performance. Don't lose sight that your company does something or another that provides value somewhere that somebody pays for so that they can make money so that you can then pay for your mortgage. And there is a corporate performance that exists too. Fine-tuning that move when you probably don't need a move was a waste. Taking the compiler version maybe was what you wanted to do. Consider swap, custom swap. If you're writing move, you should be writing swap. If you believe that the performance of whatever it is that you have requires move performance, consider that you should be writing your own custom swap for the same thing. Think about, but don't fret over noexcept. You're better off not writing it than writing it and being wrong. Determine some move guidelines for your team. Prefer explicit handling of special members.
Do you count default in that? Is that explicit? Do you use default?
Yes. But more than anything, think. Think. All right. Thank you for your time. If there are any questions. All right.
I have a question.
Yeah.
When you were discussing destructive move and that sort of thing, I guess I have a question. What does the standard assume about move from types? Does it? My understanding was that it basically didn't make any assumptions beyond being able to destroy the move from object or assign to it.
Yeah.
Is that correct or
so
not?
The standard does not talk about move for your classes. What it talks about is what do the standard library components expect from a move with one of your components. And it expects that a move results in something that can be moved into and destroyed. Beyond that, it doesn't care.
Right.
Yeah. So, and that is a discussion about what the standard library containers expect.
I guess my next either question or observation is I thought that the standard swap was now going to be implemented in terms of move, so that if I implement move semantics for my class, I don't need to implement swap. The standard swap will work just
Okay,
fine.
so
So-
standard swap is great, and will very likely get what you want most of the time. But if you're fine-tuning move, think about swap. Think about, is there something involved in the swap that's more efficient than just move? There very often is.
And in one of your examples, a couple of them, you had using standard swap, and then you made a statement about, well, don't use standard swap. Or use this so that you get the right swap. And
Yeah,
that kind of
so-
confused me.
Great question. So when you put in using standard swap, that's not saying that you're going to end up using standard swap. That's part of the lookup of how you're going to find the name. If there is a better match for a swap, if there's a swap that's inside of a namespace that's already existent for the parameters, you're going to get that swap instead. Otherwise, you're going to get the standard swap. So the correct way to write swap is using std swap, and then instead of calling std : swap, you just call swap. And then if someone has overloaded swap for that data type, you're going to get that version. Otherwise, you're going to get the std version of it.
A kind of observation. So if your class is non-default constructible, you may get away from it by not declaring and defining default constructor. But if your class is movable, then you still have to think about what it means for the class to be moved out from, the object of the class, which brings you back to the idea of what it means to be default constructible. You cannot get out of it now that we have a move semantics.
Yeah, so that's a great observation. And that observation holds true if you believe in holding some invariant to the object. But if you believe in destructive move, the end result of moving out of something is what? Right? It's a shell, it's a zombie in which you don't expect anything to happen to that object, it's just going to go away. And the end result is, you're right. What state would you put it into, right? Just the destructible state.
Move out of it destructively, but leave it in such a condition that it's destructible running correctly.
Absolutely.
Yes, it's
Only
That's
destructible.
not necessarily the same as a zombie state.
I guess for me, a zombie state is a destructible state.
It should be left in an unspecified but valid state that should be destructible.
So-
but think about if the class owns something, if it holds like a reference to something, and you never want to construct an object of the class without having this reference. It's not an optional something. So you cannot you don't define default constructor. You want this reference to be passed to the constructor, but when the object of the class is moved from, what do you do to this reference? If it's an ownership.
Well, it's not owned anymore. Isn't that right? So the pure fact that it was moved, it's no longer owned.
Right, but in the destructor, you need to know, later when the destructor for this moved out object is called, you need to know somehow that there is no ownership.
Why do you need to know for a reference?
That's a good question. I need to think more about it.
So you're asking the right questions, right? Move is hard.
When you decide, it makes it much harder to decide whether you want to use a pointer or a reference to something that you're owning. Because if you're using a pointer may be null. So it means every time, practically every method of your class must start with if is the pointer null, then assert, throw something. Otherwise, do something with the owned object.
Yeah, don't do that. So do you, after you delete a pointer, after you delete something that's being pointed to, do you look at that named variable every time afterwards to see whether or not you should do something with it? No, you're like, I deleted it, right? I shouldn't be messing with it anymore. So move, well, let's just take pure R values off the table because they don't matter, right? This is only a problem with when you say something's expiring. and you call move, right? So you're controlling it at that point, and after you've told it that you're going to move, what is it that you're going to do with that object afterwards? If you're going to move into it or you're going to let it destroy, then you don't care about the rest of the invariants. If you're able to control that. There are situations where you're not able to control that. And then you, at that point, you've got to think pretty hard about what the invariant means of something that was moved from. And that's actually hard.
I think a perfect example of what you're saying is the thought and shoes of writing the mean pointer. If somebody wants to move it, you don't own it anymore.
Yeah.
Thank you.
Yeah. Thank you for the question. All right. Thank you again for your time.
Thanks.
Oh.